here's where we are last time. Okay, we've seen how to change the view, or basically make our character, or the AI in this case, look at our character. We've seen how we can delegate our behaviors, and now we'll see, we'll have our first taste of pathfinding for our AI. Now, before we start, make a backup of this state, okay? And because we're going to see both with built-in NavMesh, and we're also going to see in the next video if we do not want to use the NavMesh, we can integrate an A star and stuff like that. So the first thing you need to do now is do a backup. Okay, so in this one we're going to see the built-in NavMesh. Now last week actually Unity 5.6 came out, and it has some more tools for the NavMesh, but we won't really necessarily care about it in this one, because there's tools to rebake them at runtime. Okay, as far as our AI concerned, we do not really care at this point, okay, about changes on the NavMesh. We just want to see a few examples of how we can work with and what we can actually do with all of that. Okay, if you're going to rebake it at runtime, it's a whole different topic. So we'll just focus on 5.5, and because I'm pretty sure 5.6 is going to have a few bugs, especially since it came out a few days ago. Okay, so the first thing we need is to create a floor. Now for the floor, and for actually the floor we actually need, doesn't need to have a collider, because the NavMesh will only bake upon mesh renderers, as you can see it over here. So for our first floor, let's create something like this. Okay, doesn't really matter. And what I'm going to do is I'm going to disable the lighting, and what we need to do is make it static, and more precisely we need a mesh that is navigation static. We should also make this navigation static, okay, because it's going to, or actually let's not, and you will see why. Let's bake. Okay, you can see that it bakes the NavMesh, but over here there is a wall. Even if we move it, it's not really has cut into the mesh. What you can do, if you want to have, well, this is on the previous one, but if you add a NavMesh obstacle, click curve, you will get, it will cut the NavMesh, and if you keep moving this, it will, update the whole. But if it's, in case this is a static wall, instead of adding an obstacle, you can simply make this also static, navigation static, and then if you rebake again, you will also get the cut. And you can see that this is also does a lot more cuts, because it's pre-baked. Okay, and because it's pre-baked, it doesn't have to worry about performance, so it cuts it as a shape. Okay, this is basically what you need to know about the NavMesh. So basically what you can, the basics of it, or what the least amount of what you will need. And of course the next thing you're going to need is, on your AI you need to put not an analytics tracker, that's for sure. You need to put a NavMesh agent, and if we zoom in, and everything is too bright at this point, okay, you can see the NavMesh agent where it sits, and if we move this up, we need to actually bring up our collider also. I think 0.5 will do. Okay, and this needs to touch. Well, it won't touch now because there's no collider on this. So let's just add one. Doesn't matter. So we can clamp this up, and we can bring the visual up. Okay, I can put it over here if I want to. It's purely visual. Okay, so have this. If you want to make sure also, you can hit play, and if you do not get an error, then that means it's at a distance. But if you put your NavMesh agent over here, well, until you start it, well, you can see you get the warning right now. Okay, it says that the agent is not enough close enough to a NavMesh. So basically what it does, it does a radius and tries to find a NavMesh, and if it finds one, it will clamp it down to the position of the NavMesh. Okay, and we should probably leave it like, maybe it's not enough. Let's see. Okay, now let's go down into our scripts. We have our NavMesh, and well, basically we're going to need a few references to our NavMesh. So let's think. Yeah, we can leave it over here since this is also AI. I think they probably put them under a namespace. Let's see. Oops. They probably did something like that. Let's see. Yeah. Okay, you need the namespace Unity engine .ai. So on start, we can go with on start, get component, NavMesh agent. Later on, and depending what your game needs, okay, you might not want to have the NavMesh agent on the same object as you will animate it, or well, basically you can do a lot of stuff. So you can have your NavMesh agent as a guide and move your enemy AI with forces, and that basically follows the NavMesh agent. Of course, that will require a bit more resources. Okay, so depending on your game and what you're actually looking forward, you're trying to make, then that will change basically. Now, and yeah, we're not going to see that because it's really rare cases. What we are looking after for is what you see over here. Okay, we have our NavMesh agent, and we will use the NavMesh agent to work with our AI, and basically we'll let the agent to do all the work. Okay, so we have our behaviors over here, and what we're going to do, we have on our in view checks. So we're basically going to make the enemy go and follow the player, and we're going to see what we can do with that. Okay, when you see the player, just go at the position of the player. So let's go over here, angle check, data was for direction. Okay, let's go over here. We can just create a new AI state, we'll see, or we might leave it for after we have covered also the pathfinding with the A star, because I want this to be a little bit more generic. So we're going to do move to position, and all we need is basically a vector 3, and we have Let's call this target position. And then if we do agent.set destination and then pass target position, that's basically all we need to move. And let's drop it inside change state instead of yeah, that actually might work, might not work, but let's drop it over here. Move to position, and the position will probably be where we have our target, player target, position. Okay, change state runs only once. Okay, and when we work with the NavMesh agent, when you use set destination, especially if you use it on each frame, that's a bad idea because you are forcing on each frame to recreate your whole path, while the NavMesh agent is actually multi-threaded, or well, it works like it's multi-threaded. I don't know if it's actually multi-threaded, but it probably is, because it can handle a lot of stuff, and I've done tests with the NavMesh agent, and it can, it can work with up to thousands and thousands of agents at a time. So that means it's really powerful, but you have to know how to use it. Otherwise, you're not going to have problems. You're just going to require a lot more performance. So the first thing to note is set destination only once. Okay, and not on every frame. Let's close this, hit play, and if we do not have anything, any problems, it will probably work just fine. Let's go. Okay, you can see he actually moves, and you can see that where he actually moved, he didn't move, and he doesn't follow us around, and that is because he only updates once. Okay, and that's something we are actually looking for. If I go out of his view, he will revert back to the idle state, as you will see over here. Let's actually lock this, and if I go again close to his view, you can see that he's firing, or he's doing the recast to see if he can see me, and only the first time he sees me, then he updates. He is going to go into that current position. Now, in the rare case that, well, not in the rare case, if you want to actually make him follow you, then that means you absolutely have to have to use this on every frame. So for example, let's take this and move it from out of there. Let's put it inside every frame, because it has a signature and it's different than the one we have on our delegate. And in radius, in view behaviors, we will drop it over here in view behaviors. Okay, let's hit play now. We should probably bring this guy a little bit closer, and now he will always run to find me. Let's open the profiler. Where is he? Profiler. Let's try and dock it, and let's see what we can get from this. Okay, you can see there are spikes, but they're not really spikes. You can see that it's 250 FPS, but without even opening this, I'm going to tell you that it's probably because it has to recalculate the NavMesh agent. Okay, and we can see what actually causes this. Well, yeah, it's not really a problem at this point. Okay, keep in mind that we're still on 250 FPS at minimum, which is really nothing. Okay, so let's see some more of these spikes. Of course, we have some physics calls, and that's probably because we have a collider somewhere that doesn't have a rigid body. Oops. Want to unlock this visual. Yeah, it could have been the player also. Anyway, it's nothing to worry about. We still have a behavior update, but we are just talking about 5 milliseconds. Okay, and we also have the log strings. The debug logs are actually awful, as you can see. Just to log a string at the console, it gives you 5 milliseconds. So yeah, maybe we should just comment this out so that we have some more, something more. And we should do over here, if rotation direction equals vector 3 0, then rotation vector will be forward. Okay, let's see. Let's hit clear. Let's hit clear, and let's play again. Now, as I can see, okay, still NavMesh Manager, it doesn't do nothing because he hasn't found us yet. But when he finds us, and when we're actually forcing, well, he lost us. When we're actually forcing for him to recalculate it, we're going to see a few calls. And basically, yeah, it's at this point it's really nothing. But if we had like 5 of these, no players, 1 AI, let's see, let's duplicate all of this, and let's see what will happen now. Let's see our spikes. NavMesh Manager, crowd collision. Okay, you can see that it starts to create somewhat of an overhead, but it's really it's really nothing, as you can see. So let's go even extra wild. AI agents gone wild, basically. Okay, so we have all these agents following us around, and we're still not even worrying. Now you can see though that the NavMesh Manager actually starts to create more of an overhead rather than everything else, but we're still pretty good at the FPSs. Okay, and you have collision, which is the agents colliding with itself, path optimization because it tries to optimize it, and then you have all your other results. Let's do this once more. We have 28, so we'll have around 60 colliders, 60 agents, and let's make around 90 colliders to the extent that I cannot even touch them. Oops. Okay, hit play. Let's gather everybody. you can see that, yeah, what's happening, and you can see that now we're on a steady frame drop at 250 FPS, and you can see that, of course, we know where it all comes from, and it's because from the transform of the NavMesh manager. But we can still work with all of this. Okay, we still do not worry about the number of the NavMesh agents we have, and you can see that we have collisions and all the rest. Okay, we can skip duplicating and duplicating. As I said, I've tried it with more than 1,000 agents, and at that point you will have to worry more about having, you know, that many capsules and all the other stuff inside your scene, rather than you have to worry about your AI agents. But okay, you can see that it's around 250 FPS. Let's see if we can fix this, or we can, you know, we can make it work with less than, you know, with less performance. So the first thing we can change is, of course, quality. Since you have all of these many, then you probably do not worry about all of this having, you know, the best obstacle avoidance. So we can raise this down to low quality. The next thing you can also untick is the repath, and you can also close the auto traversal of the off-mesh links, since that won't be really an issue. Now, and let's clear, and let's hit play, and let's just see if that changes the quality, does anything. And as you can see, it actually does. We are a lot of frames. As you can see, we've gained a lot of frames. There's no in between, so I guess it's around yeah, we can again think about 250 FPS, and because there is just lower quality pathfinding, and actually let's just make this over here. Let's gather all of them, just so that we have correct values. Okay, you can see that everybody is trying to get in place, but we keep a steady FPS rate with just checking two true options. Okay, we can see our stats, so we have all of these. Now, of course, this is just yeah, it's an extreme case. You will rarely see 100 AI agents running wild into your scenes, especially in shooter games. It's just not going to happen. If you're going to an RTS or something like that, you do not even have to use an AI agents like the NavMesh. There is actually flow maps. There's a lot of other stuff you can do. There's a lot of you can do with A star, and yeah, okay. So for our needs, the NavMesh agent is enough. So I'm going to go back and delete all of these guys, and we can work again with only one. Delete this, and let's put our player down here so that we do not care about him. We won't need the profiler anymore, so I'm going to close it, and we'll go back into our script. So we need a few places to, or a few more variables basically, to save a few stuff. So for example, I want to save last let's call this last known position, and what we're going to do right now is, in view, when you are changing a state, and you decide that you have an enemy in view, then we're going to update the last known position to what the position was. Okay, player target position. Now, instead of moving into position like this, we're going to set destination. We're still going to keep this exactly as it is, but we're going to change this from in view behaviors. We're going to take this out, and what we're going to do is place it in here again, and we can just take this and put it over here. Okay, and now we can go down here and we can say void monitor target position. We don't need a signature, and we can say we can do a distance and see if the player position, player target position, no, or let's just call this delta distance, and we want to check the distance the player currently has with the last known position. Okay, and let's just put a threshold, let's hard code the threshold. If the delta distance is higher than 2, then last known position will be a player targeted position. Okay, and we need to reinforce move to position vector 3, not vector 3, last known position. Okay, now because we actually, we're going to be using the last known position, we can just hard code this and make this to always go at the last known position, but you can also use this to move and to move your character. Okay, so for example, when we have a patrol state and stuff like that, we can just reuse the move to position, so we do not have to change that. And we should also be, I think we can make this also public and access it from another script, but we'll just see if we need this. We're going to change it into, from another, as I said, we'll see in another video. Okay, monitor target position, and now let's think. We have late frame and we have every frame. And which one of these should we add it? Okay, is there really, unless we do not want to chase our player target, is there really a reason why we should be checking if the target position has changed on every frame? Okay, as I said, since we do not want to chase the target, and chasing, that means you should probably going with the last known position. So unless you want to actually chase him and so that he never loses him from his side, you shouldn't recreate the path on every frame. So instead of adding it on every frame, let's just try with late frame, and let's call this monitor target position. Okay, and I do believe if I have this selected and my AI also, we should probably see that. Okay, we can see where the path goes. If I change the player, okay, the enemy will update the position on every 10 frames, every 15 frames, or as much frames as we have it there. Okay, and as you can see, because we are updating it on 15 frames, it's basically exactly the same thing as running it on every frame, like can you really notice any difference? Because I really can't, to be honest. Okay, and we've gotten down the how many times we ask for a new path. We've gotten down again at 15 frames, at 15 times per frame, and we can see that he's up. Not 15 times per frame, every 15th frame we recreate the path. Okay, and you can see that it also has the same behavior, the exact same behavior. If we again multiply all this, I'm not going to do it, but yeah, you can trust me on that. You can have, you will have the same effect. Now, let's go over here. Also position, that's not position. And what we can also do right now, if we change this from late frame to LL frame, okay, because it's the first one we assign, we need to actually assign it and not add it, because it won't be null. Okay, let's see if this changes something. And it just makes him feel tightly a bit slower, but you can see that we're basically calling it a new path on every if we're running. Actually, let's make sure our cases. Okay, we have 15 and 35, so that means we're basically calling it 2 times. If we're running with 60 FPS, we're less than 2 times a second. Okay, so that means even more performant, but you can see that it's slightly lower, but it's still passable. It's slightly slower, not lower, but it's still passable. Okay, in any case, it's still far better than just calling it on every frame. And yeah. And of course there's a wall over there and he cannot find us. Now let's see some other features with the NavMesh agent. For example, I'm going to create a plane. Let's drop it over here. I want to make sure it's on top of the floor we have right now. We don't need the mesh collider. We can change navigation static, and on navigation we can create a new area for this. Let's call this avoid or whatever, and we have our costs. Okay, so if walkable costs 1 point, then the avoid should cost 2 points. You can still walk on top of it if there is no other path directly leading to it, but the AI will try and avoid it if it can. If it costs less to move directly across than going around, then it will still move across. Okay, but you can change that and make this to 5. And let's see, we have navigation static, object over here. Okay, I have selected, I want mesh render, I want the plane, and I want this to be avoid, and I'm going to bake it again, and you will see that it has a new color. Let's click play and let's see. Because it sees me inside the path over here, of course he's going to ignore me and it's just going to walk across. Okay, now let's raise the site radius of this and let's make this 50. Let's make the maximum distance 80, so that the AI agent is following me across. Now let's create a few more of these. Okay, we're going to make one of this. Let's drop it over here. Let's create a few areas too. Let's call this one, doesn't matter. Let's give different costs. Object. Let's create another area. Let's call this too. Let's duplicate this, and over here let's change the object to the form, and let's rebake. Okay, so we now have, well, let's scale this up so that it at least starts with itself, and let's rebake again. Okay, it's something we actually, the NavMesh agent can work into this strip of path. So I'm going to raise it again. Okay, and now we are done. Let's click play. And you can see that it's cheaper to go all the way around than just going through each one of these. In case it cannot avoid any one of these, then he has no other choice but he's going to walk in it. So you can create a lot of stuff like this, and you can actually you can make a lot of dynamic. So you might want to have lakes, stuff like that, so it will cost more to get from inside the lake than basically go around. As you can imagine, you can do a lot of stuff with all of this. For example, let's block all of this. Let's rebake. Okay, it will still do the same, but it will now calculate if it's faster to walk around or to go through the obstacles. And in this case, it finds that it's faster to go through the obstacles than going around. If we want to force him to go around, if we go to the actual AI, and we go to the area mask, we can actually make him not be able to walk on the areas. So for example, I think 4 and 1, we closing them entirely, so we are disabling them this and this area. If we hit play, you can see that because he cannot walk in this and this one, it's cheaper to go around than going through this one. Okay, really simple. So the other thing we can do, as I said, I want to keep this a little bit more introductory, to be like an introduction for the NavMesh agent. And then once we cover also the A star, we're actually going to create behaviors for this to make him cover, go to cover, attack, patrol, all stuff like that, after we have also covered the A star. Now let's make this also static. Let's bake. You can see that we get this. Okay, so we have now upon another roof or whatever this can be, but what we can also do is we can generate off-mesh links, but for some reason I think we forgot to, let's see, agent height, jump distance, let's change this to 2, and the drop height, let's change this to 4, and let's hit bake again. And you can see that depending on the values we change over here, we auto generate off-mesh links. Now if for this to work, because for right now the auto traverse of mesh links will work for us. Let's go to the navigation. You can see that he's going to go, jump down, then go around. Okay, and this is with the automatic off mesh links. Although I think I've read that they actually disable the automatic off mesh links in 5.6. I'll have to check on that. Okay, but yeah, this is basically it. Now, if you do not want the off mesh links because this can be messy, what you can do is create your own off mesh links, and it's pretty easy to do. Let's call this start off mesh link. Okay, and the start can be its own self, we do not care, and we need also, well, we can make it as a target, as a child object, and put that on the end. Let's see where it's going to place this and what it actually does. You can see that it doesn't care about distances, it will just jump to wherever, but we do not want that, of course, and we want to place it like that. So you have your cost override, which is how much it costs to go around, and of course if it's activated or not. And you also can assign it as an area, so if you want only your player to be able to use this, you set it up by this. Let's hit play, and you will see that it's cheaper to go through the NavMesh link, through the off-mesh link, than going around. Okay, and it's also bidirectional, so it can actually go the other way. If you do not want to be bidirectional, then you simply uncheck this, and we can also, if you tick update position, up to update positions, okay, then it will follow, it will update the positions on, on runtime, depending still again on what you want to do, or if it's something you want to do with the NavMesh. Okay, you can see, of course, one problem, that is he goes linearly to that position, and yeah, of course you can change that, but yeah, it would have been best if they had at least make it implemented by themselves, or that it wasn't linearly, or that, yeah, it would have made a little bit more sense. Or actually, if you could can control it, of course you can control it since it's just a linear interpolation, so you can, you can add your own Y, you can add a curve, you can do everything you want, you can add animations. Actually, what you can do with this, so this one was kind of my very first game when I was starting out. Okay, but it's never finished actually. You can see that the stuff I do over here, it's all off-mesh links, so jumping around, you can hook them up with animations, you can do all of this. He will actually climb up, and this I believe was through 4 years ago, I think. So it's Unity 4, it's not even 5. You can see I have Bloodborne over here. Yeah, 2014, and it's on another account which I don't use anymore. Okay, so there is really a lot of stuff you can do with just the NavMesh, as you can see, and it's all smoke and mirrors, to tell you the truth, because the animation, because you've seen the linear interpolation was simple. Okay, all this is handled animation wise, so he jumps, he he rolls around, all stuff like that. It's all animation based, it's all smoke and mirrors and nothing less. Okay, well, but yeah, it looks pretty nice. So anyway, this game doesn't exist anymore, so ignore it. Now, we were over here. Okay, we've seen the NavMesh, we've seen what it can do, we've seen the off-mesh links, and we will see this more in depth as far as the AI behaviors are concerned with the in time. Okay, and we're also going to see the baking and runtime with the NavMesh, which is in 5.6. But yeah, we will see it when we actually need it, because till then we won't actually have a use for it. So there's this. Next video we're going to do exactly the same, but we're going to do it with a star. So you know what to do. Like, subscribe. If you like to see videos earlier, then you can support me on Patreon, and depending on your tier, you also have more rewards like discount codes, and also access to a Google folder where I have all the scripts. Okay, and the other way you can support me is, of course, through Gumroad, by grabbing a project or two, including the final, when this is done, the package. Okay, so I'll see you next time.